All right, so we're going to continue on with chapter 10.1. Let's move on to Venn diagrams. Okay, Venn diagrams is also something that you've done before. Venn diagrams, if you remember correctly, it goes like this, and you have A, and you have B, right? Now we have to do some nomenclature here. A cup B, or A, this is A, what? This is A and B, right? A and B, and that would be right here. So this is A and B right here, okay? And then we have A or B, or A or B, and that would be everything here. So that would be A or B, okay? Another one that comes up every once in a while is A bar complement of A. This is not A. So those that is not, so it's not A. So in other words, it would be A and B, it would look like this, right? Everything that is not A, okay? This is also written sometimes like that, okay? With an A prime on there, A prime, okay? This is the complement or the not A. Okay, so these are some of the things that we talk about. So there's a cup. I call this a cup because it's a cup. I call this a cap because it looks like a cap. All right, a hat, right? Okay, all right. So it's a union or whatever. Okay, all right. So what is the? Okay, so let's go. Example number 6 at Pascal High School. 54% of students are girls. 62% of the students play sports. Half of the girls at the school play sports. So half of the girls play sports, okay? So let's see if we can use the Venn diagram to solve these things. Example number 6. So we're going to do a Venn diagram. Okay, and we're going to have what? 54% are girls, and half of the girls play sports. So this is the girls. Okay, this is play sports. Okay, play sports. So half of the girls play sports. So out of the 54% here, half of them play sports. So I'm going to have 0.27 and 0.27 here, right? But what percent of the people play sports? We have 62% of the students play sports. So this guy here plays sports is 62%. So this guy here would be 35% because these two have to add to 62%. Okay, so what would this be here? This would be what? These are the boys who play sports, right? Because they're not girls and they play sports, okay? All right. So now also notice that when you add these together, what do we have? I have 0.54, add these together, and I plus add the 0.35, I get 0.89. So in other words, at the periphery here, I have 11%. Okay, I have 11%. So what are those people? Those people who are not girls, nor do they play sports. So the 11% here are the boys who do not play sports. Okay, all right. It's kind of an overview or overlay of what we're looking at here. A, what percent of the students who play sports are boys? So the students who play sports who are boys, again, are the 35% here, right? B, if a student is chosen at random, what is the probability that it is a boy who does not play any sports? So that would be the 11% right here, right? Boys, no sports. Okay? And so there we go. Well, wait a minute. A, what was A? What percentage of the students who play sports are boys? Oh, the percentage of students who play sports who are boys. Okay, so What percentage of the players play sports? The people who play sports are what? Are this total here, right? That's 62%. So of the 62%, the boys are 35%, right? So this is what you're looking at, right? So that was A. A, if you do that, was 56.45. 45. Okay? So that's 6. Let's go over to page 683. There's a purple box there. For events A and B in the sample space, A or B, okay, so A or B, here, girl, so let's go back and so let's say, okay, well, let's go back. A or B is what? So if this is A, and this is B, all right? If I add just the probability of A and the probability of B, is this equal to P A or B? It really isn't, right? Because what happened here? You added this, and then you add this again, so you've double counted the one in the middle here. So you have to go ahead and subtract one of those out. So we're going to subtract this guy out, and that would be A and B, right? So A or B is probability of A plus probability of B minus probability of A and B. Okay, and that's what that shows there on the top of page 683. Okay, so example number 7. At Pascal High School, example 6, 68% have cell phones, 77% have iPods, 62% have both cell phone and an iPod. Okay, so we're going to have, we'll just use this one here. So this is example 7. So this is cell phone and this is iPod. So what is the percentage of people who have both of them? 62% have both the cell phone and so this guy in here is 0.62, right? The middle guy here is 0.62. But what the percentage of people who have just a cell phone, I mean cell phones in general, cell phones together is what? Cell phones have 68% have cell phones. Okay, that means that this guy must be 6%. Okay, and then iPods are 77%. So when you add this guy to this guy, it needs to be 0.77. So this guy here is 0.15, right? Okay, so A. What is the probability a student has a cell phone or an iPod? Cell phone or an iPod, you would add these three together. Or, so in other words, we can do the one we just did, right? Probability of cell phone plus probability of iPod minus probability of both. Right? So we add this together, we get 0.68. We add this, we get 0.77. Then we're going to subtract the one in the middle, which is, subtract 0.62. We're going to get 0.83, I believe, right? 0.83, is that correct? 0.83, yeah. B, cell phone or an iPod, but not both. So cell phone or an iPod, but not both would be this guy plus this guy. So it would be 0.06 plus 0.15, 0.21. Okay? Example number 8. We're going to use what we're called a tree diagram. A tree diagram is very useful when you have a complicated situation and you're kind of could get lost. We use what is called a tree diagram. We branch off of things, okay? So let's go. We have example number 8. Example number 8. Example number 8. 2 identical cookie jars are on a counter. Jar A contains 2 chocolate chip, 2 peanut butter cookies. Jar B contains 1 chocolate chip cookie. we select a cookie at random. What is the probability that it is a chocolate chip cookie? So in jar A, we have 2 chocolate chips and 2 peanut butters, and in B we have 1 chocolate chip. So I go from here to jar A. So the probability of me picking jar A is 50%, right? I have 50 this equal the same chance of picking either one of the jars, right? So if I pick A, okay, so now what am I trying to pick? What am I trying to find? We are trying to find what is the probability that we pick a chocolate chip cookie. To pick a chocolate chip cookie, I get what? 50% is a chocolate chip, 50% is a peanut butter, right? Because I have 2 and 2, right? So the chocolate chip will be 2 out of the 4. Peanut butter will be 2 out of the 4 also. If I pick the jar B, guess what? 100% of the time, I'm going to get a chocolate chip cookie. Okay? So to get from here to this branch, I have 0.5 times 0.5. So this here is 0.5 times 0.5. To get a chocolate chip this way, I get 0.5 times the 1. So this is 0.5. This guy is 0.25. So you add these two together, so I get 0.75. So 75% of the time, I'm going to pick a chocolate chip cookie. Now notice here, you can't just add these together and say, well, I have 5 cookies and I have 3 chocolate chips, so my odds are that. That does not work because they are not equally distributed, right? There's a variance or difference whether you pick jar A or jar B. Okay? So that's A, and then we go to example, so let's go to example 9, which we talk about now, conditional probability. Conditional probability is a probability given that something has occurred. Okay? Given that something has occurred. Okay? So, and the way you denote that is probability of A happening given that B has already happened. Okay? So this is the probability of A on the condition that B has already occurred. And that's how you denote that. Okay? And if you look at that, go to page 6. Oh, let's do example number 9 first. Example number 9. Sal opens a box of dozen chocolate-covered creams. Generously offers them to Val. Okay, so this is the one we were talking about earlier, right? We were talking about earlier. So we had 4. Example number 9. And so, if 4 of the toffees are vanilla, what is the probability that both of them turn out to be vanilla, right? And we actually did this already, right? So the first one, we're going to have 4 out of 12. Once we pick the vanilla, there's 11 left, and there are 3 vanillas left, right? So now these cancel out, 1 over 11, okay? So on page 685, there are what we call independent events. Okay, independent events are where P, so the conditional event, so if I have a probability of A happening, given that B has already happened, what is the probability that A happens? And if this is the same as just that means what? It doesn't really matter whether P of this B happened or not. Again, we go back to the, are you wearing black shoes whether I show up late to school or not late to school, right? So the P of A has nothing to do with whether or not I showed up late or not, right? Okay, so this holds true if they are independent. If A and B are independent. Okay? So, blah, blah. So, therefore, in the independent events, to do P, A, and B would be the same as P of A times So, okay, so that's on page 685. That's the top blue, and the bottom blue says that whether or not they're independent, regardless of that, a conditional probability says that PAB is the same as PAB over PB. Okay, all right. So that's what happens. This is how you calculate the conditional probability. Okay. Let's do example number 10. Suppose we have drawn a cookie from random from the jars described in example number 8. Given that it is a chocolate chip cookie, what is the probability that came from jar A? So if you remember, go back to example 8. If you go to example 8, we had jar A and jar B. A and B, 0.5 again, 0.5, and we had one chocolate chip cookie here, so to get a chocolate chip cookie, this would be 1, probability of 1 here. Then over here we had 0.5 chocolate chip, 0.5 peanut butter, right? So chocolate chip cookie here, it was 0.5 times 0.5, 0.25, 0.5 times 1, chocolate chip cookie here is 0.5. So given you had a chocolate chip cookie, which means that out of the 75% total, okay, what is the probability that it came from jar A? To come from jar A was this, right? So in other words, it is 0.5 plus the 0.25, 0.25 as such, okay? So given that it was a chocolate chip cookie, this is the probability that it came from A. So I'm going to be 1/3, it looks like, right? 0.25 over 0.75, 1/3. Okay, so that's how you do conditional probabilities. All right, and we'll close out 10.1.